So I'm Professor Andreas Hornung. I'm head of the Chemical Engineering and Applied Chemistry at Aston University in Birmingham, UK. And I'm working here in the field of developing of pyrolysis reactors. Pyrolysis reactors are well known worldwide, and there are different ways of performing pyrolysis: slow pyrolysis, fast pyrolysis, or intermediate pyrolysis. And we are dealing with intermediate pyrolysis, which means we have a residence time of a biomass fed into the system of roughly 7 to 10 minutes, but a very rapid gas release of several seconds, where the gases can be trapped later on, for example, as oily and water-based liquids, or the gases can be used, for example, in a combined heat and power system. That is the main aim of developing new pyrolysis reactors, to combine these reactors with downstream aggregates, for example, for heat and power generation, or to couple the vapor phases directly to a gasifier, where these are converted into syngases and where the pyroformer takes the work to remove solid particles like char or ashes, not entering a gasifier. And this is widening the scope of biomass feedstock you can use for such a system, and that is our part of the work, to feed in all type of solid residues you can find in the world market. So residues from agriculture, residues from anaerobic digestion, residues from sewage sludge processing, even with water contents up to 48% if the vapors are directly coupled to a gasifier. So how it is done is in a way that this reactor is bearing two coaxial screws. And the screws are transporting, on the one hand, the biomass through the reactor and is pyrolyzing the biomass into the vapors. And the other screw is transporting back the char, where the char is heated again by the external heating system. And this temperature is transferred to the biomass in the mixing zone. So the mixing zone is now the crucial point where the biomass is not heated up instantaneously on a very high temperature, like in fast pyrolysis. It's smoothly heated up with the energy from the char and pyrolyzed. So the system, as I told you, is a new system concerning the inner components, but also the performance is exceptional because it's an optimized intermediate pyrolysis where we get very dry and brittle chars and very low tar liquids, which are tested, as I said, already in CHP plants, but also in the transfer to gasification units.